Last time we were talking neighborhoods, uh, just deleted neighborhood and of points. So all of you understood what is the meaning of neighborhood point and deleted neighborhood of a point, right?
Sir, can you please increase your voice level? It is not audible.
Is it okay now?
Yes, sir.
Okay, so last time we were talking about neighborhood of a point and we saw how to geometrically what is the neighborhood of a point. So neighborhood of a delta neighborhood of a point means what? If you are standing at this point A and then delta distance on right side and delta distance on left side, right? And therefore length of delta neighborhood is 2 delta. So length of delta neighborhood is 2 delta. So delta distance on one side and delta distance on another side. So that is what the delta neighborhood of point. And we denote this by n delta A or P delta A, right? So delta is just notation for the uh, distance, right? So the distance, delta is a distance. You can use any notation epsilon or sometimes we denote it by n epsilon A. Epsilon means what? The distance is epsilon. So idea of neighborhood is clear because last time we discussed it in detail. So now we want to uh, uh, discuss something more about sets of real numbers using the previous knowledge. So bounded above set. So bounded above set. So let a subset of R, then A is said to be bounded above. Set A is said to be bounded above if there is a real number U such that x is less than or equal to U for each x in A. So what is the meaning of bounded above? Set is said to be bounded above if there is a number U which is greater than or equal to every element of set. So the number U is called as an upper bound of set A, upper bound, because every element of set is less than or equal to U. So for example, if A is equal to 1, 2, 3, 4. Now can you tell me real number which is upper bound of this set?
4.
Okay, so U is equal to 4 is an upper bound of A. Now if I take u is equal to 5, isn't it upper bound?
Yes, sir.
Right, because 5 is also upper bound. Because what definition says ki u is a real number, may not be member of set, right? The only thing is ki every member of set is less than or equal to u. Is also an upper bound of A. If I take u is equal to 4.0001, isn't it upper bound?
Yes, sir.
Right, so is an upper bound of A. So u is equal to 2059 is also upper bound. Right, so you choose any number greater equal 4. But if you take u is equal to 3.9978, is it upper bound?
No.
Is not upper bound of A. That means you cannot go below 4. So 4 is something special. So you cannot go below 4, but anything greater than 4 is upper bound. Right. So what is the conclusion? What we observe from this, so this is just simple observation. I am not saying anything uh, difficult thing. So simple observation. Every number greater than or equal to 4 is an upper bound of A. So every number greater than or equal to this 4 is also upper bound. So, and note that upper bound of a set. So what we can observe from this, upper bound of a set may be member of set or can be member of set or cannot be a member of set. Right, so upper bound can be member, cannot be member, doesn't matter. 4 is upper bound, 5 is upper bound, but 5 is not member of set. Right, so this is, you can, one second observation is, uh, set can have many upper bounds, right? So set can have many upper bounds. So this set has many upper bounds. Every number greater equal 4 is upper bound. That you can observe immediately. Now, if you look at another set, uh, B is equal to those real numbers which lies in between 5, for example. You understand what is set B? All numbers between 0 to 5. So 0 is included because x greater equals 0. That means numbers greater than 0 or equal to 0 and less than 5. So what is upper bound of this set?
4.
What?
5.
5.
U is equal to 5 is upper bound of B. Now, if you choose any number, suppose I take U is equal to 4.93. Is it upper bound?
No.
No. Is not an upper bound of B. Is not upper bound. Because why? Because 5 is here and 5 is not in the set, and where is U? 4.93 is here, right? Which is less than 5. And why 4.9 is 93 is not upper bound? Why? Why it
So
is not
because
out?
there exist many real numbers between 4.9, 3 and 5.
Yes, because there are many members of set which are greater than. For upper bound, right, for real number being upper bound, what condition that number should satisfy? Each and every member of set should be less than or equal to that upper bound. So, and so why 4.93 is not upper bound? Because there are elements of B greater than 4.93, right? Because there are many members of set. Our set is 0 to 5, and these members in particular, there are, so if you look at these members which are greater than 4.93 and they are also less than 5. See, for example, which member you can catch particularly which is greater than 4.93? 4.94, right? This is member of set B and x is greater than 4.93. Right. So every member should be less than. No member should be greater than of set. Every member of set should be less than or equal to that number. Then only it is upper bound. So this is not upper bound. Now, if you look at mm, 5 is upper bound. So 0.5, 5.00001. Is it upper bound?
Yes.
Yes, sir.
Is upper bound, right? So you cannot go below 5. You cannot go below 5, and anything greater than 5 is upper bound. So 5 is somehow special, right? Like in previous example, 4 was special, and 5 is not a member of set. Even 5 is upper bound. Any number greater than 5 is upper bound. So that's why, so these are the main observations you can make from this. So right, so upper bound is clear. Now if you look at another set, C is equal to x at x greater than 0, or simply this set is 0 to infinity. Right, so what is the upper bound for this set?
So
There will be
no
no
upper.
upper bound.
No upper bound. Right, so that is the observation. From easily you can observe this set has no upper bound at all. But why? Can you write down the proof of this? This set has no upper bound. Mathematically, technically, how will you write down the proof? This set has no upper bound. That means that is set C is not bounded above. Right. So, what is the definition of upper bound? So, U is said to be bounded above if there is a real number and U is up greater equal all members of set, and number U is called as an upper bound. So, bounded above. Set is bounded above means it has some upper bound. Right. So, this set has no upper bound means this set C is not bounded above. So how will you prove it? That is, there is no U belongs to R such that X is less equal U for all X in C. There is no such U which is bigger than, greater than or equal to each member of this set C. Right? There is no such C means what? Right? No number is upper bound. No number is upper bound means what? Logically, see, you have to think logically.
The set is infinite.
No, this is a rough statement. Statement is not wrong, but this is a rough statement. You want something concrete. Uh, explanation which we can write down mathematically, and if you go give this explanation to computer, the algorithm will work. Right, you cannot tell computer to x is the set is unbounded, so or it is infinite, or so this such a statement computer cannot understand. What language computer understands? So logical language, right? So we have some logical arguments. Logical in the sense you should have some symbols, you should have some expressions, and we should have some algorithm. So logical algorithm that we can write down.
Sir, we'll first consider a u which is greater than all elements in C, and
Right,
then we can show that x plus 1 is, or x plus u is greater than u, because x contains all positive numbers, and so we can prove that u cannot be greater than x plus u. So there is no
right,
upper bound.
very good. Suppose there exists an upper bound u of for C. There exists an upper bound which is a real number for C. When I say u is a real number means u is a finite number. Do you understand? When I say u is a real number, that means it is some finite number, because everything is in real numbers is a finite number. You choose any number, it has some finite value. Suppose if this is a real line and here 0, so you choose any number which is 1000 kilometer away from 0. After all, this is a finite quantity, right? So what is not finite, which is outside real numbers, right? What is not finite, when we say something is not finite, which is outside real numbers. So anything in real numbers, so u is a finite. Suppose there exists an upper bound u for C. That means x is less than or equal to u for every uh, x in 0 to infinity, right? Or every x in C, which is our set C. So that therefore u is greater equal 0, right? U is greater equal 0. In fact u is strictly greater than 0, right? And u is a real number basically, therefore u is a member of C. Is it true? Is it the simple observation?
Yes, sir.
Right, u is greater than 0, that is clear, because u is greater than 1. 1 is a member of C. You can give more detailed explanation of this. So in mathematics, you have to give reason to each and everything, and if you are not satisfied, you give more detail. Why u is greater than 0? How will you ensure? Because 1 is in set C and u is upper bound, so u is greater than 1, and certainly it is greater than 0. So u is a member of C. Now, but u plus 1 is also member of C. Right? U plus 1 is because by definition of set C, C contains all the numbers. So if we add 1 in that, that is also member of C. Right? Because it is a set of positive numbers, and positive number contains 1 is a positive, u is a positive, so u plus 1 is positive, and u is less than u plus 1 by order properties. Right? Why u plus 1 is a member of C? So from our previous knowledge, you can give various arguments so that u plus 1 is member of C and u is less than u plus u. This is a contradiction. Why contradiction? Right?
So because
Because
we
u
can
should be greater than.
upper
Ah,
bound.
so u plus 1 is a member of C. U plus 1 is a member of C, and which is greater than upper bound, which is u, which is a contradiction, because member of set cannot be greater than upper bound. Right? So contradiction, and therefore thus What is the conclusion? Our assumption is wrong. What we assume is the set has upper bound. This we assume, and therefore we got contradiction. So we reach to the contradiction. So our assumption is wrong. There is no this set has upper bound is wrong. Thus, set C do not have an upper bound. So that is clear. So uh, just from definition, you can prove that this set has no upper bound. Okay, so now let us go to the another definition. Let a subset of R set is said to be bounded below if there exists a real number V such that V is less than or equal to X for every X in A. So if every member of set is greater or equal V, then V is called as lower bound. So then V is called as lower bound of A. So V is less than or equal to every member of set. So for example, if I take A is equal to 1, 2, 3, 4, then V is equal to 1, correct? V is equal to 1 is lower bound. Lower bound of A, correct? V is equal to 1.
Yes.
V is equal to 0.978. Is it lower bound?
Yes.
Right. And therefore any number smaller than 1 is lower bound. But if I take V is equal to 1.00019, is it lower bound?
No, sir.
No,
No,
sir.
sir.
It is not lower bound of E. Because why it is not lower bound? Because there is a member of set which is not greater than this. Which member? Right. So which member is not greater than this or greater equal this?
One.
1. 1 is a member of set which is not greater equal this V. So this V not upper bound, lower bound. Right. So if you look at set B, X such that 0 less than X less than 2. Then what are the lower bounds? So V is equal to 0 is a lower bound. V is equal to minus 1 is lower bound. V is equal to minus 0.9 is lower bound, right? So V is equal to keep your mic off. Keep your mic off. Okay, so you can understand key which numbers are lower bounds for this set, right? So 0 to 2, 0 is a lower bound, but no number greater than 0 is a lower bound, right? And every number less than 0 is lower bound. Similarly, if you look at the set C is equal to X such that X less than minus 1, right? Or this set is minus infinity to minus 1, you can. So this set does not have lower bound. Right, so by same logic you can prove it. If you assume that some v is a lower bound, then there is a contradiction. Right, so you should write down the explanation why this set does not have lower bound. Fine, so now we want to make the definition more general. A set A is said to be bounded. So what are previous two definitions? Bounded above, bounded below. That means there is somebody, some number is there which is above and all members are less equal. And bounded below means there is some number which is, there are many members in fact, but there is a member which is at the lower position and all other members are above that. So it has lower bound. So now set is bounded, right? Bounded above, bounded below, now bounded. Bounded means said to be bounded if it is bounded above as well as bounded below. Right, so set is bounded means it is bounded above as well as bounded below. So that is set A is bounded if it has an upper bound and a lower bound. Right, if it has at least one upper bound and one lower bound, then it is bounded. So for example, if I take set A is equal to 1, 2, 3, 4, 5, is it bounded set?
Yes.
Right, so this set is bounded because it has upper bound as well as lower bound. If I take x such that, so what can you say about this set?
Not bounded.
This is not bounded because it is bounded, right? So 0 to infinity, this set is actually 0 to infinity greater than 0. So it is bounded below but
not above.
bounded up, not bounded above. So bounded below but not bounded above because it has lower bound but not upper bound. So if you look at set real numbers for which x less than -1, then not bounded, not bounded because it is bounded above but not bounded below. So it is not bounded above, it is bounded above but not bounded below because -1 is upper bound or other members are upper bounds but no lower bound. So this set is not bounded, unbounded. So if you look at another set, x such that 0 less than x less than 1, then this set is
Bounded.
bounded because it has upper bound as well as lower bound. So if set is set A is not bounded, then we say that it is unbounded. So unbounded. And when we say set is not bounded or unbounded, means either it is not bounded above or not bounded below or both. So for example, set n of natural numbers. What can we say about this set? What can we say about set of
Unbounded.
so not bounded above, but it is bounded below, right? So unbounded. It is not bounded above, therefore bounded, but it is bounded below. Right, so natural numbers, one is lower bound or other numbers are also lower bound. So if you look at set of integers, it is unbounded because it is neither bounded above nor bounded below. Right. So the idea is clear, what is bounded above and bounded below set. And you can easily see which sets are bounded and which sets are unbounded. Now let is non-empty is a non-empty set. A number alpha said to be maximum element of A if, and I think we have discussed this definition earlier. So what is maximum element of A? A number alpha is said to be maximum element of set A if, when we say that alpha is a maximum element, if we remember the definition. What is the definition of maximum element? So number alpha is a maximum element if alpha is a basically member of set, and second condition, it is maximum. Maximum means what? All other members less than or equal to alpha for every member of A. Right, so that is the definition of maximum element. So basically it should be member of set. That's why we are saying set is non-empty. Right. If set is empty, then there is no question about maximum element because there is no element at all. So we should have at least one element, then we can say that it is maximum element or not. So for example, if I take set A is equal to 1, 2, 3, 4. So what is the maximum element? What is maximum
4.
element? Alpha is
4.
equal to is maximum element. But if you take alpha is equal to 5, is it maximum element?
No. No.
No, right? Because even every member of set is less than or equal to 5, but what is the condition? That maximum element should be member of set. So 5 is not member of set, right? And therefore, moreover, 4 is upper bound. Right, 4 is maximum element as well as upper bound. Now let us see another example so that you can understand difference between maximum element and upper bound. So what is maximum element of this? So u is equal to 1 is upper bound. Of B. Now what is maximum element of this set? This set is non-empty, but what is maximum element?
0.9 recurring.
So you said that alpha is equal to 0.999 recurring nines, right? What is this? 9 by 10 plus 9 by 10 square and so on. If I take 9 by 10 common, what I get in the bracket? Tell me what is in the bracket. So 9 by 10. What is in the bracket? 1. Am I right? Plus, what is next term? I am
1
taking
by
9
10.
in decimal. All of you understand? I can write this number in decimal in this.
Yes.
1 by 10. 1 by 10 its square or 1 by 10 square and so on. So this is a geometric series 1 plus r square and so on. What is the sum of geometric series? Here r is less than 1. What is r in
A
this case?
upon 1 minus r.
Right. So
Yeah,
9
cool.
10, which is 1 upon 1 minus 1 by 10. This is a simple calculation. Right. So this is 9 by 10 and 10 minus 1 9. So and 10 10 cancel. This is 10 by 9. So what is it? 1. So what is 0.99 recurring nines? What is it? This is 1 which is not member of set, right? And this is not in our set. Therefore, you cannot say 0.99. Do you understand? While talking about sequences and series, we'll discuss how this, what is the meaning of 0.99 is equivalent to 1. Because this is infinite sum and this sum converges to 1. In fact, it is 1. Right, so 0.99, this digits do not stop. That means infinitely many times 9. But ultimately where it is tending towards 1. Right, and therefore this number is not in B. So we cannot say 0.999. You understand? So what is the maximum element?
But sir, 0.9999 is always less than 1. It tends to 1, but it is less than 1.
No, this is, give me exact position. Can you give me exact position? Where is it? Where is it? Can you give me its position? If you say that its
Between
position is,
0 and 1.
where is it? So it is less than 1. You are saying it is less than 1. If it is less than 1, then there is some space between 0, that number, and 1. I can find a number from set B which is greater than that alpha then. Do you understand this? Right? So that is what we have to learn in the FYBSc calculus. The things are not so straightforward as you think, as you uh, imagine. Things are not straightforward. This is not just observe this key 0.99 is not 1, so it is 1 actually. And when it will reach to 1, because you have infinitely many digits and you calculate this number, the calculation ultimately gives me 1. And where it happens? When it happens, when you, if you are writing 999 and you should not stop, you have to write down all the digits. When this process will end? When this process will end?
It will go to infinity. No?
Right, so if you keep on writing 999 and if you the digits are infinitely many, this process will not end in finitely many years. But as a mathematics, or the power of mathematics, you can understand If you write down these 999s infinitely many times without writing without writing these numbers, you can understand what is this number is. This number is 1. Right? So that is what convergence of sequences and series, that we'll discuss in next topic. Right? And therefore this number is not less than 1, it is actually 1 if you are saying that recurring lines. When you say that it is less than 1, right, suppose this alpha is less than 1, what will happen? 1 minus alpha is positive. That means if alpha is less than 1, there is some space between alpha and 1. Right? There is some space between alpha and 1, and look at mean of them. Alpha plus 1 by 2. Where is this number? Where is this number? Is it less than 1? Is it greater than alpha? Which we already proved. If A is less than A plus B by 2 less than B. If A is less than B, which property? So let me write down in detail here. So if A is less than B and A is less than A plus B by 2 less than B. So this property, do you agree with this? Mean of two numbers in between them.
Yes, sir.
Right. Now if you say that this is 0 and this is 1, and you are saying that alpha is equal to 0.999, which is not less than 1, but suppose somebody says that it is less than 1, then there is some space between. Right, suppose alpha is less than 1. Suppose this alpha is less than 1. By this, what will happen? Where is alpha plus 1 by 2 mean? Where is mean of these two? Right, mean is here. And is mean less than 1? Is it greater than alpha? Right? Is it true?
Yes.
That means what is a contradiction? Ki there is a number x which is in between 0 and it is greater than alpha. So how alpha can be a maximum element? In fact, alpha is not a alpha is member of set. If you say, then there is a member of set which is greater than alpha. So how alpha can be maximum element? In fact, alpha is not in the set because alpha is 1. 0.99 is basically 1. But if somebody says that it is less than 1, then again a problem. So what is a 0.99 is actually not in set, it is 1 because it converges to 1. So now if there exists some number u in set B which is upper bound, so maximum element is upper bound in the set. Right, what is the definition? From definition, maximum element is a member of set and it is also upper bound, means upper bound from set. Right, if u is a member of set and it is upper bound of B, then what will happen? 0 less than u less than 1, right? And therefore x is equal to u plus 1 by 2 is greater than, therefore if, then u less than x less than 1 and x is member of B, so that u is not upper bound. Contradiction. Do you understand? Is this clear what I am saying?
Yes, sir.
So if you say that some number from set is upper bound, then it is less than 1, right? That number is less than 1. So if you say that some number is upper bound from set, then it is less than 1. Immediately I can produce x, which is a member of set, which is greater than u. So you cannot be larger than all members of set B. That is a contradiction. So what is the conclusion? Thus, what is the conclusion? B does not have an upper bound, does not have maximum element. So this set does not have maximum element. So it may have, this set has many upper bounds, but maximum element does not exist because we want to member from set which is upper bound, right? So this set does not have maximum element. Is it clear?
Yes.
Yes, sir.
Right. And therefore, what is the conclusion or observation? A set can have upper bound but may not have maximum element. Right. So set can have upper bound but may not have maximum element. So this is example. This set have many upper bounds but maximum element does not exist. So this set has maximum element as well as upper bound. So maximum element exists. Right. Now, if you look at another example, uh, C is equal to X such that, right? So what is this set? All numbers between 0 and 1 is also included. Then what is maximum element?
1.
Alpha is equal to 1. Right? So maximum element, this set clearly have a maximum element because 1 is a member of set and all other members are less equal 1. Right? So you can verify this. Now, through that, if alpha is a maximum element of A, or if maximum element exists, then alpha is an upper bound, right? This is very straightforward. If alpha is a maximum element, then certainly it is upper bound because by definition of maximum element, each member is less than or equal to alpha. Is it clear?
Yes,
Yes,
sir.
sir.
So is converse true, right? So what is the converse of this statement? What is converse?
Converse is not always true.
Right. Upper bound may not be maximum element. And this is the example. One is upper bound, but one is not maximum element. So the converse is not true. And why, you can think over it and you can write the detailed explanation. The idea is clear, then you should write, able to write in your own words. Right? Okay, so let A be a non-empty set. A number beta is said to be a number beta is a minimum element or least element, right, or smallest element of A if, right. So what are the conditions? Beta should be member of A, it must be there in the set, right, and beta is less than or equal to X, beta is less than or equal to X for all members of A. So it is a member of set and all other members are greater equal beta. So similar arguments you can make for this. So for example, if a is equal to 1, 2, 3, 4, then what is beta is 1, right? 1 is a minimum element. If I take set b is equal to x is that 0 less than x less than 1, then no minimum element, right? This set does not have minimum element. By same logic as we did for maximum element of interval 0. If you look at x such that 0 less than or equal to x less than 1, then beta is equal to 0 is minimum element, correct?
Yes.
Right. So if I take set of natural numbers, then what is beta?
1.
1.
1 is minimum element. So 1 is minimum element for this set. And this set has no maximum element. No maximum element. Right. So let a is equal to x square plus 5x plus 2 divided by x plus 1, 1 less than or equal to x less than or equal to 3. Prove that is bounded above and or prove that set is bounded. That means it is bounded above as well as bounded below. Right. So how will you prove that this set is bounded above? Or find some number such that this x square plus 5x plus 2 upon x plus 1 is less than or equal to m for all x belongs to 1 to 3. Right. So if you can find such number m, then can we say that if this set is bounded above? Do you understand?
Yes, sir. Yes.
So if you can find some number m, whatever it may be, larger number or doesn't matter, if you can produce such number m for which this absolute value less than or equal to m, then ultimately what will happen? Minus m less than or equal to x square plus 5x plus 2 upon x plus 1 is less than or equal to m for all x in 1 to 3. So if for every x this quantity is going to lie between minus m and m, that means m will be upper bound and minus m will be lower bound. There might be many, but if we are successful to produce one number m, that ultimately will give us lower bound as well as upper bound, and we can say that set is bounded above as well as bounded below, right? Every such quantity will be less than lies in between minus m and plus m. So then this every such number will be in between. So right. So this is a way we can think about it. So how to produce such number m, right? So how to produce such number m. So what we want m such that x square plus 5x plus 2 upon x plus 1 is then equal to m for all x in 1 to 3. This is we want. Now observe that. So how to make our life easy? To make our life easy, try to perform simple steps, and these simple steps we combine together, that will make our life easy, right? So x square plus 5x plus 2. Just think about numerator. By triangle inequality, it is less than or equal to x square plus 5x plus 2. Am I right?
Yes.
Now, but where is my x? X lies in between 1 to 3. But if I replace x by largest value possible, what are the possible values of x? Possible values of x are 1 between 1 and 3. What is the largest possible value?
3.
3.
And therefore, if I replace x, where is x now? X is in between somewhere 1 and 3. But if I will replace this by 3, largest possible value. I will replace x by 3 and 2 as it is, because everything is non-negative, so no need of absolute value sign. Now, what inequality I should have here? Because I am replacing x by largest possible, right? X is in between 1 and 3,
Equal.
so it is greater equal, right? Because x is in between 1 and 3, at present x is in between, so this x is in between 1 and 3, but I am replacing by larger, so this amount is larger. So what is it? 9 plus 15 plus 2. So what is this number? 24 plus 26, right? Is it correct? Is it correct?
Yes.
Yes, sir.
So I found some number which is bigger than numerator. Now I want to produce a number which is, again, next I want, what next? Next we want 1 upon x plus 1 less than some number, right? What is this number? 1 upon x plus 1 less than some number. That is what we want. Absolute less than some number, you can say p, right? That is what we want. Absolute value of x plus 1 is greater than 1 by p. That means we want a number which is less than absolute value of x plus 1. That is what we want. Correct? Am I right?
Yes.
Yes, sir.
So since 1 less than x less equal 3, our x is positive, therefore x plus 1 is positive quantity, right? If x is less than x is in between 1 and 3, then x plus 1 is greater than 0. Ultimately it is greater than 2, actually greater equal to, am I right? Which is positive quantity. It's correct.
Yes.
And therefore absolute value of x plus 1 is greater equal to. So what is the quantity I wanted to find? 1 by p is now 2. And therefore 1 upon absolute value of x plus 1 is less than or equal to 1 by 2. So we have two expressions. This is first expression and this is second expression. Now combine 1 and 2. From 1 and 2, what we get? Absolute value of x square plus 5x plus 2 upon x plus 1, right? Which is actually x square plus 5x plus 2 upon x plus 1. Am I right? But the numerator x square plus 5x plus 2 is less than or equal to 26, and 1 upon absolute value of x plus 1 is less than or equal to half. So this the whole thing is less than or equal to 26 by 2. Am I right? This is correct. This
Yes,
is the
sir.
number which is the number which we wanted to produce, right? And this is true for all x is in between 1 and 3. And what is the conclusion? We can produce a number which bounds above as well as below to such numbers. Okay, so this idea is clear now. This idea is clear.
Yes.
Yes.
Right, so you think over it.